Hi, Chris Kuzmal here. We're going to be talking today about linked lists. A linked list contains a sequence of elements. For example, the names or strings representing the names of my family, Chris, Tracy, James, and Jane, in order of age. Rather than referencing to each element by index, so Chris would be 0, Tracy would be at index 1, James at index 1, Jane at index 2. Uh, I'm sorry, Tracy is at index 1, James is at index 2, Jane is at index 3. That's how we do it with an array. In a linked list, we have what's called a pointer between each element in the list. Okay. So a doubly linked list has attributes of a head. It has something called the head, which just sort of refers to the beginning of the list. Um, and that head might be null, might not contain anything. Each element of the list contains three attributes. The previous element, or a reference to, or also known as a pointer to the previous element, which is null if it's the first element. A key, which is just a value stored for that element in the list. In our example, it's going to be the names of the members of the family. And then a pointer to the next element in the list, which of course is null if it's the last element of the list. Let's look at an example. A doubly linked list of 4 elements. If the first element, suppose it's located at location 31, then the previous field will be null, the key field will be Chris, and the next field will be the address of whatever the next element is. And I chose 41 as the next location. And if we look at memory location 41, Tracy, we will refer to this line as referring to Tracy. The previous element is at location 31. So this 31 here acts as a pointer to the previous element. And the 59 is the memory location of where the next element is stored. And so if we look at memory location 59, we have James, which has its previous locations at 41, and the next location is at 26. Notice 26 is earlier in the memory, but it's subsequent in the list. And so Jane is stored at location 26, but her previous element is stored at location 59, and the next element is null. And so this is how you can think about a doubly linked list. In fact, there's even more indirection and pointers going on than I'm even showing here, but I hope this strikes a balance between too abstract and too detailed. One way of representing this whole list is just to show each of the keys with a double arrow between each of them in the order in which they appear. And this is the usual way you might write a linked list. Now, this is mysterious doubly linked list, as if you're sort of doing something extra complicated. Let's quickly look at a singly linked list. All that's happening here is each element does not have a pointer to the previous element. So Chris points to 41, but Tracy doesn't point back to Chris. Tracy points to James, James points to Jane, Jane points to null, and that's it. And if we were to draw it, it'd be exactly the same as a doubly linked list, except each element is pointing to its successor, but not to its predecessor. That's doubly and singly linked lists.